Make it work, make it beautiful, make it fast. So if you've been in the Beam community for a while, you might have heard this already. The quote is usually attributed to Ken Beck. Is an American scientist, the person behind the Agile Manifesto and things like extreme programming and test-driven development and all of that. And if you've been to Dave's talk yesterday, this should sound very familiar. In there was this acronym, like a crewman, where one of the key concepts there was the A in writing software. What was the A? What's the A standing for? Acceptance? No, appropriate. So if you don't write appropriate code that is functioning correctly, that is well tested, it has literally no sense to spend time in writing a robust, scalable system and going into the next layers. The reason why this quote is very famous in the Beam community is because it was picked by Joe Armstrong in several occasions. So in one of the historical Erlang books, Erlang NOTP in Actions, Martin Logan, one of the authors, remembers this encounter with Joe, which gave a slightly variation of this. Make it work, then make it beautiful, then if you really, really have to, make it fast. And then he continued. 90% of the time, if you make it beautiful, it will already be fast, so really just make it beautiful. Unless you are Mihao and you're implementing the JSON library for Erlang. I'm Roberto. I work at WhatsApp. I've been there for the last couple of years. I work in a team which is called WhatsApp Developer Infrastructure. Together with my team, I'm responsible for the Erlang developer experience at WhatsApp. So one way to look at this is that we try and help WhatsApp developers and Erlang developers in general to write functioning, beautiful code. And we try to do that through tools, and we open source as much as possible what we do. So if we go back for a second and think about the make it work, make it beautiful, make it fast, I can easily reason about make it work. In my mind, I kind of understand what it means. I'm writing a program, so I'm writing it in Erlang, so I suspect that I need a valid syntax. I have a perfect tool that can enforce that kind of thing. So I can use a compiler to tell me if my code is correct. I can run it, and hopefully I can ensure that it does what it's supposed to do if I have tests, if I do a bunch of other things, and I have assumptions like I have specifications of what my program should do, and I encode those in tests. But what about beautiful code? Yeah, make it work is okay, but what does it mean to make code beautiful? Is it because it's elegantly written? Is it because it transmits like the elegance of thought that was behind? Is it because it's readable? Is it because it's well formatted? Is it because it has type specifications? Is it because we use things like process isolation and actor model and message passing? Is it because we separate communication with like algorithms? What is it? Like, imagine that you're coming to the Beam community for the first time and you're writing code. How do you know if your code is actually beautiful, if you're writing good code? I thought about this a bit, and well, a kind of obvious answer is you start applying all kind of general patterns and principles that you may be aware of. If you have a background in computer science, maybe you studied these things at university. You studied patterns and software engineering. Maybe you don't have a computer science background and you learn from practice. You read books, you went to conferences, you listened to other people. There was a talk, I think this year at ElixirConf by José Valim. I think it was called The Gang of No One. It's basically like he went through some of the design patterns from the Gang of Four book and tried to apply them to Elixir and how you would map into a world with processes and message passing. And if you haven't watched that talk, you should definitely do that. But in general, you have this kind of like a general knowledge. You ask your colleagues, you have code reviews where you think about what is good code. Then if we go a bit more specific, for example, into Erlang, the probably next go-to place is the Erlang reference manual. It's an amazing resource. It's full of information. It contains things like the efficiency guide. It contains the common caveats, and it tells you a bunch of things on how to write good Erlang code. If you are appending to list, you shouldn't do this. You should do this other thing instead. Case statement, if statement, when you should use one or the other, how you do like efficient recursive functions and whatnot. Then we have a bunch of other guidelines. We have the Erlang Ecosystem Foundation. It has working groups, and I don't know if you know this, but one of the working groups, the security working group, created a bunch of guidelines saying what you should do to build software in a reliable way, in a secure way, because beautiful also means like secure and safe. So if you go through this document, you will find things like, oh, you should probably not generate atoms at runtime. It's a pretty bad idea. Atoms in Erlang are not garbage collected. So if you have this idea of taking a username and using an atom to represent it, you may be unlucky after 1 million or so usernames. We have community guidelines. So occasionally, once in a while, people start writing what code should look like. How many know about Inaka and the guidelines? That's pretty good. So Inaka was this very nice South American, partially distributed, I think, company that ended up, I think, acquired by Erlang Solutions in a way or another. And they brought a bunch of tools. So one of the things that they actually delivered was this set of guidelines on how to write beautiful code. So, and this is more focused on when you call a function, you shouldn't have too many arguments. When you write case statements, you shouldn't nest them unnecessarily. You should use functions instead. You shouldn't have modules which are too long. And they even wrote a tool, a linter, that can detect some of these problems. It's called ELPs. Then you have project-based guidelines, project-specific guidelines. This screenshot is taken from the Rebar 3 contribution guidelines. Rebar 3 is one of the most popular build tools for Erlang. And there you have things like, please do not add trailing white spaces. Please use spaces, not tabs. So it goes more into the formatting side of things. And it also touches on, please don't do nested case statements and so on. My point is that there is a whole hierarchy of guidelines in the community that defines what is beautiful code. Now that we kind of agree on what beautiful code is, and agreeing is a very strong word, we have another problem. We have to detect violations. So we need to figure out a way to tell developers whether their code is beautiful or not. Most trivial and naive way of doing this is through code reviews. You have a bunch of experts, and they will nitpick at your pull requests. So if you have a trailing white space, they will tell you, they open it in Emacs, they have a big red giant block, and they will scream in horror and will tell you, don't do that. If you write code which is very complicated, they will tell you, yeah, you should decompose this. The compiler itself has a nice linter that runs when you compile and can identify problems, like if you have an unused variable and you don't use it, you get a compiler warning say, hey, this variable is unused. You should probably prepend it with an underscore, or maybe you should use that variable and it's a bug. You have tools like the formatter. And like this is very opinionated, but the formatter can basically prevent from having all this category of discussions around what the code should look like. So very opinionated, but my take, just use a formatter. We have something which is called ERLFMT in the Erlang community. It does a wonderful job. You just apply the formatter. You don't have discussions in pull requests on how the code should look like. You save your file. It's automatically formatted. You submit it. If you write code that is not according to the guidelines, you get an error in CI. And that's a time saver. Maybe it's not the most beautiful code, but it's consistent. And consistency has like no price. You have other tools. You have linters, like the Elvis by Inaka, that you can run. You can do like Elvis rock, and it will find problems in your program. You also have static analysis tools. You have type checkers. If you haven't used Equalizer, you should give it a try. You add type specifications to your code. You make your code more beautiful, meaning that you are writing the intent of each function. You are defining what the expected input is, what the expected output is, and you actually get clarity about what the function should do just by looking at the signature of a function. And the type checker will identify problems. Today, we will learn how we can make our code beautiful using a tool that we developed at WhatsApp in the past couple of years. It's called ELP, or the Erlang Language Platform. And how many of you are familiar with ELP itself? How many use it? Aha. So, I will not cover in detail what ELP is, because there was a talk. I gave a talk at this same venue, smaller room, about ELP. So you can go there and learn what ELP is and how it works. The one-slide version of this is ELP is code intelligence for Erlang. It's a database of live facts about the code base, and it's also a platform for building other tools. The reason why ELP is mostly known in the Erlang community is because it comes with a language server, which is how most people interact with ELP. A language server is this thing in the IDE which provides features such as go-to definition or code completion. You heard that the Elixir community is creating now a team with 4 people fully dedicated to write a language server. We have several language servers, and I think in a pretty good shape in the Erlang community already. So one thing that people are not aware of is that ELP is not just a language server. It's a tool. It comes with a command line interface, and I want to show you that. But let's start in the IDE with an extremely simple module. It's a very trivial module. It's called CodeBeam Europe 2024. As a function that does nothing. There is something in this code which does not make it beautiful. There is something in this code which is rude. Can anyone tell me what is it? You don't need the include lib. But let's say that you were not here. Brujo was still having coffee outside. So we don't know that. We can do a very simple thing. Assuming like this is VS Code, but ELP runs in all major editors supporting LSP, so Emacs and Vim and whatnot. So we install the ELP extension. Not many people do that. And one of the reasons might be because when you search for Erlang, the first thing that you see is this Erlang with 176,000 stars and so on. So ELP is the other extension, the one that looks less Erlang than anything else. It doesn't have an E from Erlang. It's this black with the map syntax kind of thing. That's the one. So we install it and reload the window. Suddenly we see we don't need Brujo. ELP tells us that, hey, you have an unused header. You're including a logger.hrl there. And you're not using any definition from that module, so from that header. So you can basically get rid of it. And notice that these are not warnings that the compiler emits right now. Like this is all coming from ELP that does some kind of check on the code. As I said, one thing that is usually underestimated about ELP is that it comes with a powerful command line interface. So let's try to do the same through the command line. We have an ELP command. So in VS Code, you can download an extension, but ELP is open source. It's available on GitHub. We have releases. We have precompiled binaries for Linux and Mac, no Windows, I think. and with different architectures. Even in the worst case, if you don't have a precompiled version, you can either request it or you can download the code and compile it. We invoke the ELP command with the lint subcommand, and we pass the module that we just saw. What you get is exactly the same information. You get a diagnostic. Diagnostic is LSP jargon for warnings and errors. Yes?
Does it terminate with status 1 or something?
I'll go back. So, but yes. So you get the diagnostics. So on line 5, you have an unused header file. You can even pass the format JSON option so that you can get this output in like very structured format, which is great if you want to programmatically use ELP. Imagine that you have a massive code base with a bunch of diagnostics, warnings, and errors in your code, and you want to track them. This is a very nice way and easy way to do. And as you can imagine, it would be very nice if you could use ELP as part of your CI, not necessarily as a language server. Having it as a language server gives you the consistency of the experience. In the IDE, I see exactly what I see in CI. I see exactly what I can see on the CLI. Turns out that the Erlang Ecosystem Foundation created a project which is called Setup ELP. I haven't tried yet, but it basically provides a GitHub action which will install for you ELP and the equalizer type checker that runs through ELP, so that essentially in your GitHub workflows, you can add one line and say import this action, and you suddenly have ELP. So you can run ELP lint in your CI with like literally zero setup. Let's go back to the example. There are a couple of extra things that we can see here. One is that we got this unused header file, and this warning is associated with a unique error code, W0020. I'll go back to that one. The other thing is that you have a quick fix button. So if you click on that button, you get a little bulb with possible remediations on how to solve this problem. Elvis, the linter, was detecting problems. ELP can detect and fix problems for you. So if we click on the remove unused include, you basically the code disappears. This is possible because ELP includes a bunch of built-in blocks for refactoring and code modding, where by code modding, I mean the possibility of automating code changes to make automatic pull requests and whatnot. I will not go in detail about the refactoring capabilities of ELP because there was another talk last year by Alan Zimmerman, Refactoring Made Easy, where he goes through some of the refactoring capabilities that ELP already provides. So let's go back to the command line. Remember what we did in the IDE? We clicked on the little button and we got rid of the unused header. We can do the same. ELP lint. We pass the module name. We apply 2 extra arguments, apply fix in place, self-explanatory. It means apply the fix that you can find and do it in place. So it basically changes the code. You can just submit a diff. And remember when I said there was a unique error code associated with the warning? Well, we have to pass that code because we need to tell ELP what kind of warning we want to fix. You could have several. And you get back like a diff. This is like, will change the code in place. One more example. This is a common test test suite. Anyone familiar with common test? Okay, testing framework for Erlang. A lot of boilerplate here. The entry point is this all function, which lists the tests. And you have a my test function, which represents a test case. And we have some initialization in the init pursuit, and we have some tear down in the end pursuit. There are several things which are not beautiful here, but we are using meck. That's okay. It's not. We are using meck, which is a mocking framework for Erlang, to create a mock, and we are passing some options which are not relevant. Can anyone tell me what is wrong about this code? What is non-beautiful? This is not even on the beautiful side. This is on the functioning side. There's a big problem with this code. Not you. Let's run ELP. ELP will tell you, oh, there is a problem with the meck invocation. You're calling meck new, and the warning is actually not very descriptive. It says missing no link option. Well, what is happening is that when you use meck, meck creates like a mock under the hood, and it does this by creating a process. And this process is by default linked. And because of the way common test works, the init pursuit is run in a separate process from the process that runs the actual test case. So what can happen is that you create a mock, you link it by default, and the mock could actually die before you reach the test case. So if you are familiar with Erlang and you've been working with common test and meck, this is all trivial. But for someone that is approaching the community for the first time, there's a lot of cognitive load that you have to carry with you to understand what the problem is about. Remember that error code that I showed you before? There's one little thing that I didn't say. You can click it. And you can go to something which we call the Erlang error index. It's a catalog of errors for Erlang, which is essentially like an explanation of what the problem is. So you don't need to go crazy and try to ask like Stack Overflow or ChatGPT what is wrong. You can actually go there and see what the problem is, an example, a good explanation, and possible remediations for this. And the important thing is that this is all open source, it's all markdown, and everyone can contribute and populate with content. This is not a novel idea. This concept of an error index already exists in other communities. There is a Rust error index, there is a Haskell error index, and our idea is that we want to prepare an EEP or proposal of some sort for the OTP team to actually standardize this. I think it would be an amazing addition, not just for Erlang, but also for like Elixir. Imagine having all the dialyzer problems like cataloged so that you have an explanation with possible remediations. Again, you can do the same through the command line. You have an ELP explain command, you pass the code, and well, right now it's naively implemented. It will just point to the URL of the page, but it's all markdown, so we could actually render it and present it to you. One more example. Module, there is a main function. We are starting to do something more interesting. There is a problem. Can anyone tell me where the problem is? It's also easy because it's underlined. We are leaking atoms. We are generating atoms, right? We should be using something like a list to existing atom. But is it necessarily a problem? Well, we don't know. Maybe this is an e-script that I use from my command line, and then I don't really care. The atom is not existing at runtime. I could do something like create the atom beforehand, but maybe I don't care at all. And I'm totally fine with the list to atom in my code. That's why ELP provides also a mechanism to suppress warnings and errors. We have these annotations that look like Erlang comments. So you have the Erlang comment symbol, and then you have an ELP ignore, and then the error code. Each error code also has a human-readable version of it, so that it's a little easier to understand. In this case, it's atoms exhaustion. You can use them interchangeably, and you can also append a custom description for the warning. So you basically give some context to the next reader, like why this is safe. Adding an ignore annotation is a very powerful thing that you're doing. You're basically telling the tool that you're taking full responsibility about the problem. The tool will not inform you about this problem ever again. You have a variant of this, which is the ELP fix me annotation, which has a slightly different semantics. A fix me means I acknowledge this is a problem, but I'm not in the right spot to fix this right now. I'm probably filing a task for later so I can fix it later. And this is a brilliant way to annotate your code. If you have, for example, if you're adopting ELP for the first time, you don't want to go into the IDE and have like strobe lights, kind of warnings and errors all over the place. You can silence them, you can suppress them initially with fixmes, and then you can incrementally work on them. And what's important is that when you invoke ELP lint from the CLI, you can actually pass an additional argument, which is this include suppressed, which if you use fixme annotation will still report the problems. If you use an ignore annotation, it will not, because you're basically saying this is a false positive. I take full responsibility. Another thing that is quite exciting in ELP is that ELP is type aware. ELP is tightly connected with the equalizer type checker. And I must say that writing Erlang with ELP and equalizer in your IDE kind of changes the way you think about the language. It's a completely different experience. I see Elixir is kind of going in that direction with the first warnings about the types. But in Erlang already now, if you use ELP, you have this thing where you can hover variables and expressions, and you can actually see the type of that expression, like while you're writing the code, which is amazing. And we started exploring like what we can do with this information. So we started to add a couple of quick fixes. So in this case, we have a function that returns an integer, but the type signature says that this is supposed to return an OK tuple with the number. ELP will actually notice this, so equalizer behind the scenes, notice that this is a problem. You get an error there, like you have an inconsistent spec, and you can apply like whatever fix you like. You can either update the return value so that it's wrapped in a tuple, or you can just adjust the spec. And this might sound like a very trivial thing, but this is all like, it massively increases your efficiency when you're writing code. Another feature that people are not really aware of is the ELP shell. ELP comes with a REPL, essentially, where most of the work today is around equalizer. Assume that you have a significant code base written in Erlang. What you can do is that you can open your editor, open a terminal with the ELP shell. From within the shell, you can run equalize all. That will run the type checker on the entire code base. And then you can keep updating your code and write your code. And whenever you want to type check it, not just like for the current module, which is what you get by default in the IDE right now, but you want for the entire code base, you can just switch to the shell, run and equalize all, and that will only do the like minimum incremental computation which is needed, so it's massively faster. Takeaways from this. ELP, the Erlang language platform, is not just about VS Code. It's not a plugin for an editor. It's not just a language server. It's a lot more. It's a refactoring tool. It has a CLI. You can use it as a linter and whatnot. You can use ELP to detect and enforce good coding practices. A lot of WhatsApp has a significant Erlang code base, so we try to write checker for like all the bad smells that we can identify in the code, and these are generally useful. And the most important thing is that you can actually help, and we would really appreciate that help. There are a few ways you can do this. The easiest one is to just download it and give it a try. If there is something you don't like, let us know. Open a feature request, open a bug report. We have a team maintaining ELP, among other things, so we'll be absolutely happy to give support. But you can also contribute. And if it sounds scary to contribute to like a project which has a like significant architecture, there are easy ways to contribute. For example, you can contribute assists and quick fixes. It's a much, much more scoped way to provide. Like if there is a code smell that you believe you can identify in the code, you can write a checker for this. You can write a new diagnostic, and suddenly you would have this signal in CI, in the IDE, and whatnot. The unused header is a trivial example. Also, I mentioned this error index, and that's Markdown, that's open source, and I think that's an extremely good contribution point. You can go there, not all the content is ready, so there are pages where you go visit the error code and there is no example, there is no content. Start with that. If you know about what the problem means and how to solve the problem, contribute with that. That's all I had for today, so if there is time, I'm happy to take questions.
Yeah, so I think we have time for maybe a couple questions. Does anybody? Yeah?
Yeah, first of all, I know how this will sound, so please know that from a human perspective, I expect your answer to be yes, not to be no, as it will be. Because the question is, should I discontinue support for Elvis and Hank and stuff like that, and just contribute to this project instead?
I'm a great fan of competition. So there is Elvis can do things like it does an analysis per module. So you're very limited in what you can do. And you can detect problems, you cannot solve problems. I think a good exercise would be to go through the Elvis rules and see what is already available in ELP. And if everything is possible to implement, it would would be superseding Elvis, essentially.
Cool.
Somebody else? Yes.
So thank you for creating this tool. Is there a list of refactoring rules, and can you define them yourself?
So on the refactoring side, so right now the code, our goal would be to be able to enable developers to write this refactoring in the most declarative possible way. So you don't have to go there and write a lot of code. We have some building blocks, but we are not there yet. So you have helpers. So for example, like a trivial example is, so you can write the new refactorings. It's trivial. It supports LSP, so you can do the refactoring through LSP. You essentially compute a text edit, like a modification in the file, and you can send it back to the client that can apply that. And we have wrappers around things like add an export to the export list. And then inside the building block, you can do things like, oh, what if I have multiple? And what if I want to put them in their correct order? And what I want to do this? So you can either work on the helpers and make them more useful, or you can work on new refactorings. I think there are several refactorings which are still missing. I think even things like renaming some stuff. So you can probably rename a function, but maybe you cannot rename a type, for example. And that would be a very nice contribution.
Thank you.